Hey there.
Direct variation.
So today we are going to write and graph an equation of direct variation.
So the constant of variation for a direct variation, k, so whenever we talk about direct variation, we're referring to that k, is the coefficient of x. So direct variation is y equals kx.
So that's your function form. That's the form of the equation, or the formula if you want to call it that. So that's what the equation is going to look like. And then you can also see the ratio in the direct variation. This is going to make a lot more sense once we show you what it actually looks like with numbers.
Yep.
All right.
So we're looking for the form, does k equal y over x? That's what we're looking for.
Okay.
So right here, does the equation represent a direct variation? If so, find the constant of variation. So what was the formula that we just said? It was y equals
kx.
Okay. So we need to get y alone. So right here, they divided by 7, divide by 7. So does this look like y equals kx?
Yes. Yeah. So k in this form is 2/7.
Okay. So my direct variation, or my constant of variation, is
2/7.
2/7.
The direct variation is simply just that situation.
Right.
Okay.
Okay, got it.
So
here's the other one.
B.
Can we rearrange this to look like y equals kx?
So let's solve for y. So the first thing I want to do is get rid of the x, which they subtracted the 4x and moved it over to the other side. Then they had to divide everything by 3.
Yep.
So they divided 8 by 3 and 4 by 3. And so they ended up with y equals 8/3 minus 4 over 3x.
Okay.
Well, I do have 4 over 3x.
Right.
But I also have another amount in
this
there.
extra guy.
And so this would not represent a direct variation.
Okay.
So let's look again. So we want
can we solve this for
y equals kx?
Okay. So I want to get y alone. Divide by 4. So y equals 5 over 4x. Is that in the same form?
Yes. Then the next question says, what is the constant of variation? Well, the constant of variation is the coefficient of x, or the number in front of x. So my constant of variation is 5/4.
And I leave it as 5/4.
Yeah,
correct?
don't change it to a decimal, the end. So in this one, solving for y, want to get rid of my x first, so subtract 2x from both sides. So I have 3y equals.
Does it matter which one I put first?
It really doesn't. You can put negative 2x plus 6.
Okay.
And again, I can't combine those two because they're not like terms.
Right.
Divide by 3 everywhere.
Okay.
So I have y equals negative 2/3 x plus 2.
Okay.
This
is y equals kx. Ooh, then I have leftover.
Right. So this is no. So that's it. You just write no, and there's no constant of variation.
Okay.
Okay, so now we're going to go backwards. We're going to write it in direct variation form. So
and it's a 2-part step. So write this in direct variation form. Then what is it when x is 9?
Okay. So, and it tells me, suppose y varies directly with x. And y is 35 and x is 5. So it already tells me this is a direct variation. So I'm going to start with my function form, y equals kx. And then I'm going to substitute in the numbers where they go. Again, you're just plugging. You're not even chugging.
Just plugging.
Just the plug.
We're finding k.
And then we're solving for k.
Okay.
And then plug that in for k.
Then once you get this far, plug in 9.
So let's look at.
I was like, we'll get you through this.
Yeah. So let's look at what this really is going to work. Okay. Suppose y varies directly with x. Y equals 40. And when x equals 8. So we want to start with our direct variation form, y equals kx. We're going to plug in our numbers. So y is 40.
Okay.
So 40 equals k 8, or k times 8.
Okay.
So now we're going to,
solve for k.
Yeah, so divide by 8, divide by 8. So 5 equals k.
Okay.
Now I take k and put it back into that original red equation. So
I rewrite my direct variation equation.
y equals
kx, right?
Oh, and so then I'm going to put 5 where k is. So y equals 5x. And there's part 1 of my answer.
Part 1.
The second part is, now, what is the value of y when x is 12?
Okay.
So I'm going to plug in y equals 5 times 12, and 5 times 12 is 60, right? Yep.
So there's your two answers.
Okay.
So as long as you're showing your work, you should be able to get this.
Yeah, this is super simple.
No, I'm not crazy about this question. It's a little complex. So it says, suppose $15 in the U.S. is worth about 150 Mexican pesos. Okay. What is an equation that relates U.S. dollars, X they want you to use, to Mexican pesos, Y?
Okay.
So what's an equation that we can use that tells us that $15 in U.S. is 150 Mexican pesos?
Well, I already know the answer, but I don't know how to get there.
See, and I don't know how to tell them either.
So I think what this is saying is that pesos directly varies with dollars.
Okay.
So let's...
But it's not a one-to-one ratio.
No.
Okay.
So we need to figure out what that actual ratio is and solve and find our constant of variation.
Okay.
So we're going to start with our y equals kx.
Okay. So I'll do that right down here.
And we know that we have US dollars is x and Mexican pesos is y. Because it told me that in the problem. So I'm going to put 15 where the x is. And I'm going to put 150 where the pesos are.
Okay.
And then my k. And then I'm going to solve for k to get my constant of variation. So now I have k is equal to 10, right?
Yep.
Okay, now I can plug that back in to my equation, y equals 10x.
We all follow that?
I did.
Yeah. Got it.
So then they've made a table, which I don't necessarily know if we have to. Oh, yeah, we do because it says what is the graph. Okay, so we're going to plug in some information in our table, 0, 2, 4, 6, 1, 2, 3, 4.
Plug them in.
Whatever you want. Really, ultimately, it could be anything.
Right.
So then plug.
But it can't be negative because we're dealing with dollars.
Oh, right. Totally.
Yep.
So, but I could do 10, 20, 30, 40.
Yep.
And then I'm going to plot those on my graph. So $0 US is 0 pesos. If I have $2, I would have 20 pesos, and so on. So you're going to graph these dots.
Right. No, I didn't do that right.
It would be 2, 4, 6 here. And then the pesos going up the y-axis.
And then you plot those, and then
you're done.
Okay. Okay, so now we're going to view it from a table.
Yes. Okay, so again, we're solving for k to find that constant variation. Sorry, we had to redo here.
Yep.
So again, we're going to set up ratios. Y over x.
So what we've been working with the whole time. So does k equal y over x? Well, in this case, we actually have values that we can put in there. So y is 6 over my x, which is 4. Then I have 12 over 8. Then k is 15 over 10. Well, those aren't the same, but
do they have equivalent ratios?
Right.
Meaning, if I divide it out, find a decimal, they all equal 1.5.
Which we see right here.
So what we say is this definitely has y varying directly with x. So it's a direct variation, and the equation is y equals 1.5 x.
Okay, so you're telling me that I use what k is equal to.
Right.
So I don't use any of these numbers given. I have to find what k is and then plug it in.
Find the ratio between each one.
Okay.
So let's look at B. They did 3.2 over 2, over negative 2, excuse me.
Over x. Okay.
And then they did 2.4 over 1, and then 1.6 over 4, and then they divided them out.
Okay.
And as you can see, they got different decimal values for each one of those ratios.
So negative 1.6, 2.4, and 1.4.
So then, because y over x does not give us the same data, this is not direct variation.
Okay. And then we can just use our math logic there, because we see that we have a positive divided by a negative, and nowhere else is there a negative.
Oh,
so
yeah, duh.
Right away, you should know. You could know. So let's try this.
Okay. So again, we're doing k equals y over x, or y equals k over x, or k divided by...
Well,
no, k equals y over x, which ultimately means y divided by x. So we're going to do 5 divided by 2.
Okay.
Don't you think?
Yeah. Let me see that.
No. No, our tools went away. Oh, well.
Oh, geez, back to red. Okay.
5 divided by 2. And then 15 divided by 6.
Okay, so we're just doing y over x.
And then 25 divided by 10.
Okay.
So if I divide each one of these out into decimal form, it's going to give me a ratio of 1.5. Nope, 2.5.
15 divided by 6, that's
2.
2.5.
Yep, and 2.5 there.
Okay, so k is 2.5.
So now I have to plop that into, so clearly since I got the same 2.5 every time, y varies directly with x.
Okay.
So this is a direct variation.
So
and
do you want me to say yes is a direct variation, or is just yes okay?
It's up to you. I said I'm okay with yes.
I'm okay with yes as well.
And then if it does, write the equation. So we would write y equals 2.5x.
Okay.
Okay. Yay, we got it.
Yay, we know what we're doing. Another one.
Okay, so again, k equals y over x.
Okay.
So we're going to do 7 over 1, and then 10 over 3, and then 13 over 5.
Got it.
7 divided by 1 is 7. 10 divided by 3 is 3.3 repeating. And 13 divided by 5 is
Neither of those.
2 point something.
Yeah.
So this is a no.
It's the no.
Oh, I love that.
There you go. No.
All right, so here's your lesson check. Again, you're going to want to use the equation. You're going to want to say yes or no and talk about those ratios.
Yep.
The end. We'll see you
On the flip side.
Sayonara.